All right, let's get started on our next discussion here. We're talking about linear functions and equations, so that's what they look like. Here's one that's in standard form that hasn't been solved for y. There's one that has been solved for y. In fact, it's that one that's been solved for y, so now it's in slope-intercept form. And here's one that's written in using function notation, that little f of x that's out front that means the same thing as y. So what we're going to do today is we're just going to get some of these equations and we're going to just pick or choose some inputs to put into the graph, and then we'll get some outputs, and then we can just plot some points. So this is another way of just graphing an equation, a little bit different than some of the other methods that we have used. So let's pick a couple of inputs, and the trick here is to pick inputs that we can predict will not take us off the graph with our outputs. So we usually use some small numbers like, some of my favorite ones are 1, 0, and -1. So what would be our output if we use those numbers? Well, we would have 2 times 1 plus 5 to give us an output of 7. So our ordered pair would be 1, comma 7 for this first one. Then what if we put in 0? We'd have 2 times 0 plus 5. 2 times 0 is 0. 0 plus 5 is 5. So our next ordered pair would be 0, comma 5. And our last one, in this case, 2 times -1 plus 5. So 2 times -1 would be -2, and -2 plus 5 is 3. So our ordered pair on this one is -1 and 3. And now all you have to do is graph those 3 points. So over 1 up 7. The x value first, then the y value next. So 1, comma 7. That takes care of that one. Then 0, comma 5. So over 0 up 5. That takes care of that one. And then backwards 1 and up 3. So in -1 and 1, 2, 3. And that takes care of that one. So there's our graph, and then we kind of zip on down like that. So that's how you use inputs and outputs on an input-output table to graph a linear function. Let's try some more. These are kind of fun. Let's pick some nice values. It looks like if we did -1, 0, and 1, those would be some nice values that would keep us really close to the origin. And we could use bigger numbers if we wanted, but it's nice to stay close to home, right? So if I put in -1 up here, this is going to be the negative of -1, because that negative didn't go away, plus 4. Then it's going to be the negative of 0 plus 4. And then if I put in the number 1 up here, that will give me -1 plus 4. So you need to watch how this negative sign is treated as you do this, because you're putting each of these 3 numbers in for x, and you have to take that into account. So the negative of -1 is 1, and 1 plus 4 would be 5. The negative of 0 is a 0. 0 plus 4 is 4. And -1 plus 4 is 3. So here is our ordered pair, -1 and 5. So -1 and 1, 2, 3, 4, 5. And 0 and 0, comma 4, 1, 2, 3, 4. And 1, comma 3. So over 1 and up 1, 2, 3. And we notice we've got a slope of -1, so we can actually kind of chart this back out through there, and then if we had a ruler or could draw a nice straight line, it would come zipping down through like that. Okay, let's try another one. This one got some little different numbers. So let's get our inputs in there, find some outputs. So once again, if I put in a 0 here, I'm going to get 0 minus 2. If I put in a 1, I'm going to get a negative 3 minus 2, which would put me at negative 5. If I put in 2, that's going to give me negative 6 minus 2, which would be negative 8, almost off the screen. So we better go with 0, negative 1, and 1, the same three numbers we've been using all along. And it doesn't matter what order you write them on the table, usually from smallest to greatest, but in this case I didn't quite do that. So negative 3 is going to be multiplied by input of 0, and then a 0 minus 2 is going to give me an output of negative 2, right? Because 0 minus 2 is negative 2. How about negative 3 times negative 1 and then minus 2? Well, negative 3 times negative 1 is 3. 3 minus 1 equals 2. Well, what if we put in the number 1? Negative 3 times the number 1, and then we're going to subtract 2. So negative 3 times 1 is negative 3. Negative 3 minus 2 is negative 5. And so there we go. We've got our ordered pairs. 0, negative 2. So let's graph that, 0, negative 2. Then we've got negative 1 and 2. So negative 1 and 1, 2. And then our last one is 1 comma negative 5. So that would be over 1 to the right and down 1, 2, 3, 4, 5. And there we go. So we're right through the heart of downtown. Looks pretty good, except I got a little crooked with my graphic. Got to be careful about that. Okay, we got one more. This one, we've got 1/3 for our first number. So in this case, we can start with 0, but the next two numbers that we choose, I want them to be divisible by 3 so that when I multiply them by 1/3, the fraction will go away. So I'm going to go, my next number I'm going to put in is 3, because that's divisible by 3, and then I could also put in negative 3. So let's figure out what that would be. So 1/3 times 0 minus 4. So that would give us 0 comma negative 4. Then we've got 1/3 times 3, which would give us the number 1, and 1 minus 4 would be, 1 minus 4 would be negative 3. So 3 and negative 3. And then 1/3 times negative 3. So 1/3 times negative 3 would be negative 1. And negative 1 minus 4 more would be negative 5. So negative 3 and negative 5. All right, so let's graph those. 0 and negative 4 would be, we start at 0 and go down to negative 4. Then we go over to 3, 1, 2, 3, and down 1, 2, oh wait, up 3, 1, 2, 3. No, we got to remember that's 3 and negative 3. So let's get back on track there. So when we graph that one, we're going to go over 3 and down 1, 2, 3. And then the next one, we're going to go back 3 and down 5. So 1, 2, 3, 1, 2, 3, 4, 5. And lo and behold, it shouldn't be anybody's surprise that it found a straight line, and that's the graph of that function. And you notice it has a positive 1/3 slope, so up 1/3, up 1/3. You can kind of see it written right in that line. So we got another worksheet called Graphing a Line Using a Table. And we'll have you work on that this week. Thank you very much.